What's up, everybody? Welcome to Flux Harmonic. I'm David Wilson, and today we're back with another live coding stream where we try to build some creative tools using Scheme and C. And last week we had a lot of fun working on the very basic beginning parts of the program Flux Compose that I started. And this week we're going to continue on that and try to see where we can get and pick up basically where we left off last time. Before I get too much into this, I would like to say hello to Bill Scherer and Mr. Bill. We have both Bills representing today. I appreciate you both being here. I think my video looks a little bit orange. I have the window open because I have like a nice view of the sun outside, so I apologize for the effect that it has on the camera, but the sun's going to go down probably about an hour anyway, so you'll have a nice change in the coloring as the stream goes on. Get a little bit of a chai tea here to get things going. Yeah, Benzel. Yeah, it's fun for me to code for other people also. I don't know, it's a weird experience. It's kind of stressful, but at the same time, it's nice. And I really enjoy being able to build things that are interesting to me on the stream because it's more fun. And once we actually get a result, it's going to be really cool, I think. All right, so today, the goal is to try to continue encoding the information about the scene to be rendered in the rendering thread. I'll get more into the details about that in a moment, but that's basically where we left off last time. I think what happened was we were trying to encode the scene data in C just as a test. We were trying to set up some structs in C and basically statically initialize them to try to run it through the renderer and see if it can actually render things correctly. I had a little bit of trouble with the C syntax for that. And then we tried to do things on the scheme side. We're gonna continue on both fronts today just to see if we can get that finally finished up and then see where we can go from there. So updates today. Since last time, I've received a few issues and pull requests, which is pretty surprising to me. I didn't actually expect to see any issues or pull requests this early in the game, but thank you to both Christian and Felipe for sending in pull requests and issues. Both of them, had very good suggestions, and I think I merged one of Felipe's PRs that may have fixed the issues we had with setting up the structs on the C side. So we're going to see how that goes when we try it out in a little bit, which is going to be great. Also improve the README with some basic hacking instructions. I mean, it's very, very early now to be trying to use this code, but if you are so inclined, you can follow the instructions on the README on the site. Let me just pull it up really quickly. There's not much there. I mean, I'm sort of assuming that you are comfortable with Emacs and Geeks enough to go install the necessary packages, but there's just, a little bit of information there about how to get set up. So yeah, if you're interested in trying that out, definitely let me know how it goes. And I've moved around a little bit of the code. So I took some time this morning to clean things up a little bit because there's certain administrative tasks that don't really seem very interesting to do on stream. So I figured it might be better to spend some time off stream, just cleaning things up a little bit and improving the situation with the make files. Previously to doing this project, I haven't actually messed with make files very much. I don't really know much about them, but I spent some time reading this morning the GNU make manual and made some progress cleaning it up to the extent that now it's easier to add new files going forward, and I kind of understand the structure of things better. So just a quick little overview here. We basically have everything set up where we can build Flux Compose and the libflux dynamic library through this all target. And then we've got some more sort of, variables and little make trickery to basically make it so that all I have to do is just edit this obj list here to add new source files to be compiled as part of Flux Compose. I also moved the code for lib.c, the libflux library, into a different folder. I moved it into the lib folder now. So now we have both lib and source. I had seen a suggestion about doing this on some, a couple websites, I guess, basically about how to structure C and C++ projects. And it sounded like, source was a place you would want to put your application code, and lib is a place where you would want to put auxiliary libraries that are part of the code base, or maybe even third-party libraries. So I've got my lib folder here that has lib.c, and it has its own make file. So very similar to the other make file I just showed you. It has the ability to just express the list of object files that need to be produced to build the final libflux.so. And then the main make file here for Flux Compose is able to call into that make file by using make-C lib. So it can just basically invoke the make file from that folder. I don't know if this is the best way to approach that, but it's been working just fine so far. So that's the approach we're going to use, at least for now. I had also considered the possibility of going ahead and trying to use CMake or Meson for this purpose, but I felt like it was a little bit too overkill to use a build script generator at this stage of the game because we don't really have a complicated project yet. So maybe it's better to start from just using a regular old makefile and GCC and just see how far we can get with it for now. Ashraz mentions, oh, that's the new tab bar mode in action. Really like the key plus command in it. Yeah, so I did spend a unnecessary amount of time customizing tab bar mode over the last couple days, and I'm quite happy with it actually. Maybe I'll talk about that more on the System Crafter stream this Friday. But I did manage to get keycast pretty reliably in here now, so you can actually see which keys I'm typing, and thankfully I can turn it off whenever it's in the mini buffer, so I don't expose any passwords or anything. So that's kind of a nice little benefit there. Okay, what's the next thing? Okay, I also spent a little bit of time thinking about the Zig programming language this weekend. It's always been sort of like the second contender for the native code side of this project, mainly because I like the fact that it has the ability to, with its own compiler, compile both Zig and C code. It has its own nice build language, so you don't need to use makefiles. You don't need to use any other kind of complicated build system. And it also can do cross-platform compilation very easily, though that's not really something I'm concerned with right now. So I had been thinking about this weekend switching to use Zig instead of C for this project. But the more I thought about it, the more I just sort of felt like C itself is just so ubiquitous and available to everything. C library can be pulled into just about any kind of language and interacted with directly. It's very simple and straightforward. I mean, obviously it has a lot of sharp edges, but that's part of the fun for me. So for now, we're going to stick with C because I just feel like this sort of, what's the right word? Affinity towards it. So I want to stick with it, see how far I can go. I've actually been reading a couple different books on C this weekend to sort of brush up on my skills. One of them is the classic Kernighan and Ritchie, the C programming language book, which is, I don't know, in the beginning of the book, it's a little bit too beginner level. I feel like it's like very slow in the beginning if you already sort of know the semantics of the language, but I'm hoping that it picks up towards the middle and end. Also started reading a book called Extreme C, which is supposed to be like, modern C programming patterns for like application development. It's okay. It has some stuff in there, but by far the most impactful resource I've ever found as far as learning more about how to write C code. Let me see if I can find this really quickly. It's a video on YouTube. It's like a 2-hour talk called How I Write C. And I was watching that last night. I watched the first half of that last night, and that's just like an incredible talk.
Question.
Oh, goodness. I'm not going to be... Anyway, let me just put the link to this in the notes because I don't really feel like watching an ad. But basically, this guy just goes through his whole process for how he develops applications with C, and you get to see how you would do some of the more advanced application programming patterns and some really good best practices for how you can write C programs. And I'm basically taking that as inspiration for any C code that I write from here forward because it's got a lot of really good tips in it. So let me just actually jump right over here to the notes and drop this this link. Video How I Write C. Highly recommended. I like it so much that I actually want to go and write like a blog post to pull out all the stuff that I think is really interesting about that video because there's just so many gems in it that I really need to have my own compendium of information about what I saw in that video. Ashra says, CMake is a powerful tool, but at this state, it might be a bit overkill indeed. It's great for multi-target, many libraries executable scenarios, though. Yeah, definitely. CMake and Meson and any of those other types of tools would be great if we had hundreds of source files or maybe 15 libraries or something. But right now, I think make files are good enough, especially now that I've learned enough makefile syntax to get by. I think that, you know, the scope of this project probably won't even need to go any further than that, but we'll see how things go over time. Ashra says, which C standard will you target? C11, C99? I don't know for sure. So that video that I mentioned, the author of that video actually says that he sticks with C89 and not even C99 or C11 because he said that there are issues with them. I don't really know. I haven't used either of them. My experience with C, C was the first programming language that I actually started learning for real whenever I was pretty young. And I used whatever was around at the time. I had a book called Teach Yourself C in 21 Days. And I started working through that book and learned how to write some code. Then I kind of moved up to C++. So that's like the area of my C knowledge is that far back. So I don't really know what's happened in C since then, but I don't really feel like I need any bells and whistles necessarily. Ashraz, if you have some suggestions on that, I would certainly be interested to hear your opinion. But for now, I'm just going to stick with whatever GCC gives me by default. And if I have a good reason to change, I will change. Technomog says, I have Modern C by Jens Gudstedt set aside, but I haven't had time for it yet. Came recommended somewhere on Hacker News. Yeah, that was one of them I was actually highly considering. But I think there were a couple reviews on Amazon that sort of put me off it. But I probably will get it anyway, because I really want to find all of the patterns I can get to do, you know, really high quality C coding, because I just feel like there's probably a lot of satisfaction to be had from writing like really high quality C code. Especially because, you know, it can last forever. Because if you use an old C standard, all these compilers basically still compile it, and you can compile to whatever platforms you want. So I feel like, you know, it maximizes your potential as a programmer if you can just stick to C and find some good patterns for developing with that. Let's see. So I think that's it for the updates for now. But yeah, I'm excited to continue working with C because I think it's a great language. I mean, as far as Zig development is concerned, I think that the language has a lot of promise. But when you think about, you know, how many years C's been, how many years C has existed, and how much tooling is built on top of it, and the fact that Zig is, while a promising language and tool set, you know, it's still not even 1.0 yet, and there's a very, very small team of people who are actively working on it. It makes you not as confident in depending on it as a tool just yet, but I may change my mind and go start using it, you know, a month from now, 2 months from now. It just really just depends on where my interests shift to next. But for now, C, like I said. All right, so today the primary task is to figure out the right way, or finish basically figuring out how to encode C structs from Scheme. Guile Scheme has some pretty easy to use APIs for it, but we haven't actually gotten it to work yet. It could be the case that we get it working in about 30 minutes and we can sort of move on to building out more of the data structures, which would be nice. If we can get something rendering on screen with this stuff, that would be a really good result today. But there are some questions I have about how it's going to work. First of all, do we need to worry about memory alignment? If you know anything about how C structs are represented in memory, basically the order of the fields of the struct is the order in which the data for that struct is stored in memory. However, it's not just packed in right next to each other in memory. There are going to be little padding bytes here and there to align things with like the word size of the processor architecture. So I think that Guile has a way to deal with that for us. When we define a C struct in Guile, I believe it knows how to deal with alignment automatically. I'm hoping it's going to work to the extent that I don't have to think about it, but we may have to think a little bit about it if it does become a problem. And also, what about nested data? If you have a struct inside your struct, how does that work? I mean, going back to the same idea of before, a C struct is packed, or it's sort of packed. I guess it's you know, each field is in order in memory. And if you have another struct, you basically just continues on right there with the nested data. So as long as Guile can encode all that correctly, we may not have a whole lot of difficulty getting this to work. There's one thing I was just thinking about. Oh yeah, one last thing for the updates. I did not manage to get a summary video out this week. What happened was I actually sat down this weekend to try to edit a summary video using the 6 hours of stream recording from last week, and I managed to cut down the first stream recording of 3 hours to about an hour and a half. By the point where I was like, okay, this is just not gonna work. I can't be spending hours trying to edit this thing down. So what I've decided is that it's probably gonna be better if I actually record a fresh video explaining the progress of the week and maybe taking some specific clips out to inject into that to show what we accomplished. And maybe make those videos about 10 to 15 minutes max. Better to be about 10 minutes. So I'm hoping to go with that approach instead. I think it's gonna be a lot easier, and it's not gonna give me a headache every week. So I didn't manage to get that out this week, but I'll make up for it next week by trying to compress, you know, last week and this week into a single summary video that can go out so everybody can catch up in case you missed some of the stuff that happened before. Ashra says the alignment also depends on compiler specific attributes. So as soon as we start fiddling around with attribute, we might have some fun in the Dwarf's Fortress sense at hand. Yeah, I had never heard of attribute before until probably yesterday, and I didn't realize you had the ability to tweak the compiler settings using that, or turn a struct into a tightly packed struct using attributes. So that's new to me, and maybe we can find some ways to abuse, or I mean, use that behavior to our advantage, but maybe we won't have to, I don't know. By the way, if you don't mind, if you're here right now, if you could like the stream, just so that it helps YouTube say, oh, people actually like this thing, so that it pushes out to other people. I'd appreciate it. All right, so tasks today. We basically copied over many of the tasks from last time to start with today. First of all, try to finish instantiating a test scene in C. Like I mentioned before, Felipe sent a fix for the syntax I was using before. I think that should actually resolve the problem so that we can use that data structure. So I'm hoping that we can just turn that on and have it work. Also, we need to figure out how to create the C struct representation for scene objects, which when I say scene object, is sort of just a term I came up with last time for the things that are going to be rendered in the rendering thread. We need to find a way to represent those in Scheme. So we do have an API in Guile to do this, and we're going to try to continue using that. I don't think we got to a point yesterday where we could actually try the encoded struct on the C side, so we're going to try to do that pretty soon too. Also, transmit drawing instructions to the renderer thread in some form. So we need to do this in a way that is not going to cause us synchronization issues. And I think the easiest way to do that so far is just to use an SDL event. If I can push an event into the event queue for SDL, then the main loop of the rendering thread can just pick up that event and then swap out the scene data before it renders again. So I think that's probably the best way to quickly iterate without having to worry about any kind of locking semantics. And then we need to get back to getting that basic GFX example working. If we can get encoding of information from Scheme to C working, and if we can transmit that information to the render thread, then we should be able to get that example working so that we can actually write the description of the graphics in Scheme and then show them in the preview window interactively, just continue to tweak the variables and then see what it does. And if we can get to that point today, that's going to be pretty exciting, I think. And then obviously make sure we can reeval the Scheme code to update the live preview. I think if we have gotten to this point, then that should just work, but we'll see. And then finally, I want to try to render the completed image, which is going to be extremely simple for now, to a PNG file. I think we figured that out last time, how to accomplish it. Yeah, I don't have the notes right there, but should be easy. So we can get that done too. And if we make it this far, we might try to load and render an image file. So I'm sort of aiming toward the possibility of making system crafters and flux harmonic thumbnails with this code, and one of the prerequisites would be I need to take a background image for the thumbnail and place it on the rendering surface so that could be the background basically of the thumbnail. So we'll have to try that also if we get to it. Okie dokie. So that's it for the tasks. So let me take a little sip of tea and then we'll get started. So as always, please feel free to offer any suggestions or questions or anything in the chat while I'm going, and I'll pick those up as soon as I can. So let's go and try to, let me pull up the right shell here. I've done a lot of tweaking on this. Let's see, I probably want a vterm. I've done a lot of tweaking on the tab bar setup plus project.el. I've managed to get rid of, well, I don't really use projectile much right now, and I don't use perspective.el anymore, which I think is pretty cool. I'll have to talk more about that on Friday. So let's go to, what file is it? lib.c, is that where we want to go? Yeah, so we're going to go back here. We're going to take a look at this code that Felipe tweaked. So what we were doing before is we were setting up the test scene as a statically initialized struct. And the scene data structure itself has a member count and a pointer to basically an array of scene member items. And a scene member itself is a scene member type struct, which says what type it is and then what the actual properties are. And usually you're going to plug in one of these specific types, like colored, or really just circle type, rectangle type, text type, image type, that kind of thing. So we'll flesh that out whenever we get to it. Hi, John. So let's see if this actually compiles. I mean, I think it does compile because I was compiling the code earlier today. So, oh, make not found. Let me do this. Geeks shell -- pure. I also figured out one thing earlier today. If you are using Geeks and you've got GCC installed and you've maybe got an older version, and then you use Geeks shell and you've got GCC installed that's a newer version, then you might get compiler issues that seem very strange. And it's definitely better to use this -- pure parameter. In fact, let me just go to the README and just add that into the instructions, because what pure does is it clears out all environment variables before it sets up the environment, so that you don't get any cruft from your LD library path or your include path, etc., that doesn't need to show up in there. So now I can just run make here. It says nothing to be done. Let me make clean just so we can see it happening from scratch. Make. All right, so all those are compiling now. I've got some warnings here because I turned on -w all for all the warnings, which is great because it gives some useful stuff that we might have to address in a little while. And now it's built. So let's see. What I want to do, current scene equals test scene, current scene. Let me see where this is actually at right now. So in the render scene function, Ashra says, what are the two GCC versions? Probably 10 and 11. I'm not sure exactly, but somehow there was something that caused some weird compilation issues actually in standard.io.h. I don't know why it was causing issues there, but it was a very strange error that I was getting back from that. And it's an error that when I Google it, it doesn't show up anywhere. So it's apparently such a rare situation. I've actually seen it before with Geeks, and I keep forgetting how I fix it until I fix it again, and then I remember what the problem was. Render scene. So we're looking at current scene. Let me see, do I check that? Okay, I'm checking current scene, and we call render scene. So now we actually have current scene set to this test scene. So as long as we start up the graphics thread, then it should try to render that scene, just this test scene right here. So what we need to do then is to go into, let's try basic graphics at SCM. We'll take this out for right now. In fact, we'll take this out too. What we really just want to do is show the preview window. So I'm going to use Control-CR to start the REPL. And that seems to be right. And then I'm going to eval this buffer, if I remember the right binding for that. Let's see, geyser eval, Control C, Control B. All right, so Control C, Control B. Gives me an exception, probably something due to my scheme code. Graphics line 20. Let's check that out really quickly. Graphics line 20. Okay, so I don't actually have a body in this let. Let's just say T render graphic. Oh, I think in scheme it needs to be a hash T. That should be enough to make it happy, I think. So I'm gonna kill the REPL, and then I'm gonna use Control C R to run it again, and then I can go back into basic graphics, Control C, Control B, and source expression failed to match any pattern in form make scene. Let me check that one too. Apparently I've got some mess left over here. Oh yeah, make scene doesn't have a body. Let's just put dash or hash T in there also. That's one of the problems with scheme is you're not going to know that you've got issues until you try to run it. Okay, so Control C, Control B. Bad let and let form. Jeez. Okay, so I'm looking at the parens. Which file is that? It must be the one that I'm evaluating. So let's try. It's not. It could be make filled circle based on what I just saw, but let me jump to basic graphics. Okay, that one's not got anything in it. What don't you like about my let? Oh, okay, the make C struct is actually outside. So I probably should have tried to clean all this up before we got here, but we're making progress. We're almost done. Control C R, and then we'll go back here. I need a quicker way to eval something. All right, so, oh, that's the wrong file. Let me go to basic graphics, Control C, Control B. Oh, all right, so that did actually work. But why is the dimensions looking like this? Let's actually check libc. Did I get the width and height backwards? It seems wrong. I must have put something backwards. Okay, width, height, init graphics thread. 1280 by 720. I need to get CCLS running in here. Let's see, LSP. Let's see if it actually starts up for us. Import root from. Oh, come on. Import it from lib. All right, so now let's see if I can get a signature on SDL create window. And it doesn't like it. Probably because I need to set up some stuff for the CCLS config. All right, so we're gonna just go to SDL create window and just load up the docs for that really quickly. I know this is not the best way to do this, but we're just gonna get this going right now. I thought that it was width and height. It's weird that it seems to be backwards. I'm hoping that it's not something that is being caused by EXWM somehow. Let me see if I can resize this. It doesn't let me resize it. Well, I mean, it's nice that that it actually rendered something. I like that, but it's strange that it's not rendering correctly. Window pause and undefined. All right, so X, Y, those are correct. So we have these, we don't care where the window position is. We have the width and the height, and then the flags. So let me just double check window flags in case we need to put something else there. Full screen desktop, window usable with OpenGL context. I probably want that. Allow high DPI. Probably don't need to set that up. Mouse capture always on top. Okay, so I'll probably put in this window OpenGL since we do want that at some point. Let me just drop that right there. Can I clean this up a little bit? I don't know. I need a C formatter. If anybody has any suggestions for one I can drop in here, that'd be helpful. That's probably not going to help the problem, but let's see. I'll go back to our vterm. Let's see. I don't want to open a new one. I want the same one. vterm 2. So we're going to run make. Nothing can be done for all. Okay, I don't like that. So for some reason, the make file is not correctly detecting. Yeah, that's not nice. So I have to go to lib and make. But the problem I'm seeing here is that the way that I'm building the sub project for the library, it makes it so that let's see, make file. Because there's no input file to check the timestamp on, then it doesn't know that libflux needs to be updated because we're just shelling out to make to build the sub project. So I have to go and tell lib to build directly. So that's a little bit annoying, but we'll deal with it for now. Ashra says maybe sealing format together with sealing format Emacs package. Yeah, I could definitely try those. That would be useful. Okay, so let's go back to vterm. I think. Nah, maybe we need to just go to Control-C-R, pull up the REPL, then we can go back to basic graphics. I need to get a better flow for this. I think what I want to do actually is set an active project. And since I now have an Emacs package that I've been writing for this, tools/flux compose, I could potentially have a variable def var flux compose current project. We'll go with that for now. It's probably going to need some tweaks, but we'll say nil by default, and the current.scm file that will be loaded when the REPL starts. Why did it just disappear? Okay. So now if there's, I could actually set, let's see, geyser guile. There's probably like an argument list I can use. A init file, initialization file with user code for the guile REPL. I could probably use that, but I kind of don't want to use that specific argument for this. Extra keywords, minimum version. Case sensitive, load init file p. Okay, so maybe there's just a geyser arg list, geyser REPL arg list. Can't really be something I can use because it's got that dash in it. What did I just do? Arg list. Okay. Get arg list, define caller. So start REPL. This must be where it's launching the process. Let me just see if I can figure out. It's really weird if they don't give you a way to inject arguments. Geyser REPL arguments. If I have to, I'll just use the init file for that. Looking for init in here, initialization files. Okay, so the binary. Skip version check, guile init file is not equivalent to changing guile's initialization file because the former is loaded with the -L flag. I see. Okay, so flag. They used that term before. Okay, anyway, let's just try that. Let's see, geyser guile init file. Initialization file with user code to for the guile REPL. So let's try that. We can set geyser guile init file and then give it flux compose current project. And that's going to override it just for calling the geyser REPL here. And So I could set, let's see, defun, flux compose, what's a good name for this? Set current project. It's not a good name, but that's what we're gonna go with right now. Optional project file. Interactive, let's see, which one is interactive? Is F? Let's see. Emacs interactive command. I need to find what the prompt variables are, basically. Interactive function, file, directory. You know, there's a channel called System Crafters that made a video about this. Let's see if they have anything in the show notes. Videos, learning. I need to update that list. Managing files and directories, is that the one? No. It's defining function commands. So, no, I don't want the video. Where's the notes? I'm not pointing to my own notes files here on the site. Great. There are some things I need to update, apparently. So, why can't I scroll? Doing something really weird. Interactive. So that's in. Did I even mention this? Or did I link to the docs? Interactive codes. There it is. Okay, good. File. D for directory. F for the file name of an existing file. The default directory is default directory. Cool. So I'll use F, lowercase f for that. And let's see. I forgot how to get the actual value that comes out of it then. Is it just a result of interactive? Probably. See, see, interactive examples file. No. Interactive P. Oh, it's the actual argument. Okay. So, let's just say message, set, current, project, S, project file. Let's just try it out really quickly. Flux set, current project. I'll set that to examples, basic graphics at SCM. Cool, so that worked. Now what I'm gonna do is set Q flux compose current project. And I can actually set that in my dir locals if I want to also, just to sort of save myself some time. So if I do all this, and let me eval that too, because I don't think I've done that yet. In fact, let's just eval the buffer, eval buffer. Okay, so I'll set current project. I'm gonna go back, set examples, basic graphics at SCM, wrong number of arguments because I obviously am not reading what I'm writing. All right, we're gonna re-eval that, run the command one more time, examples, basic graphics. Okay, so now, whenever I run the REPL, it should actually pull up the file that I want. So let's kill this instance of the REPL, Control C R. Cool, so it worked. And was I trying to verify any change here? No, I think I turned the, Ashra says you probably don't want project file to be optional. You're right about that. Very strange that it has this dimension. Let me just flip it around and see if that makes it any better. So we're gonna go and delete the optional off of that. All right, so the other thing that we need to come up with is a better way to sort of interactively recompile and just start the REPL without me having to go and do more clicks, but we'll deal with that in a moment. I think we've got a sort of good basis right now to speed up our REPL interactions and testing out a project. So we're gonna go to lib.c, and like I said, I'm gonna just flip this around really quickly and see if that's the problem. I don't know why it would be the problem. It makes no sense to me why all of a sudden 1280 that these parameters would be swapped. I hope that it's not EXWM doing something really strange. All right, so we need to go to vterm. Actually, hold on a second. we're going to use compile instead. Compile. And then we're in the lib folder, so that should be fine. Make. Cool. Oh, make not found. Shit, I need to use the shell. That's the reason why I haven't used compile so far. So I need to somehow pick up the environment of Geek's shell. And honestly, I might be able to do that. Hold on a second. Because Geek Shell does not do anything if the profile is the same as it was before. So let me go into vterm. If I can skip that part, that's going to be helpful because I don't like having to switch buffer so many times. Okay, so Geek's Shell pure dash dash make. Oh, okay. In Geek Shell, yeah, that makes sense. Dash dash make. Creating an empty environment. That did not do what I thought it would. Make command not found. Okay. That's strange. So that must not be the thing. Maybe it's dash C or something. Let's look at help. User container root pure manifest development. Yeah, it's dash dash command. Why did it not work? Is it a bug in Geeks or am I doing something wrong? Let's skip the dash dash pure for now. No package is specified. That doesn't make sense. Unless you have to be explicit about it. So if I pull the manifest, it's dash... Where is it? Dash M? Dash M. Okay, let's try that instead. Dash M manifest.scm. Okay, cool. That's probably all that's needed. So if I just grab that... then I should be able to compile and drop this in and then use ... on that manifest. Great. That's excellent. Okay, so that's fast enough. I think I can deal with that. And we've got the same output information. Cool. So Control C R. Oh, that's even weirder. Okay, something very bizarre is happening here. I don't understand what's happening. Does it have something to do with how I'm rendering everything in the end? Let's just delete that and then open that up again. So we're going to run recompile. I probably should have a key binding for that as well. Control C R. Boom. All right. So that was pretty fast. Why is it so tall? That's what I want to know. So if I were to try to... No such file directory. What are you talking about? Okay. I was trying to like pull up some way to measure how big that is because it seems like the height is wrong somehow. I don't exactly know what happened to the height. So 500, 500. I'm not doing anything out of the ordinary here. How about if I just turn off rendering for just a moment and see if that helps. XWin info. Thanks, Bill. That actually is probably the right way to do that. All right, so I'm going to drop that into comments really quickly. We're going to run recompile, and then we're going to run the REPL again. Okay, so that seems more squarish unless I'm wrong. Still, it doesn't make any sense why it's so tall. Well, okay, so maybe we can forget about that for a second. Because it doesn't make a whole lot of sense. I think the last time we streamed, it seemed to be the right size. So I don't know exactly what happened there, but we'll continue forward for the moment. The good news is that the circle is rendering whenever I undo that code and recompile. Wait, what did I just do? Where is it? Okay, so it's back together. Okay, so let me see. It's Control C, Control R. Okay, let me go into my fluxcompose.el. I'm going to set up a binding for Control C, Control R to I wonder if I run compile, if it will let me run the next thing right after. So what if I do this? Let's try it. I don't know if it's going to work, but whoops. Let's see. Define, flux, compose, compile, and restart. Interactive, I think it needs to be. And then we're going to run flux, compose, start, REPL, and we're also going to run recompile first. So let's try that and see if it allows us to do a full loop without having to fiddle around very much. In fact, I'm going to check the documentation on recompile really quickly. Recompile the program. Reuse the arguments for the original use. Yes. Does it return anything? Command. I don't know. That seems to be part of the let. Compilation start. Returns the compilation buffer. Okay, so that's not going to be helpful. Because we need to know when compilation finishes. I think I had this problem in the past. Okay, so that's fine. Let's just go back to what we had before. And I'll go back to trying to set up a binding for recompile. Maybe we'll find another way to deal with that at some point. Recompile. Okay. So I'll set that binding up. And then now I can Control-C, Control-R. That recompiles, Control-C-R to pull the REPL back up. That's faster. Okay. So the circle looks all right. It's not bad. It rendered what we told it to, which is good. So let's move on. We've verified that we can actually describe a scene and have it render, which is great news. I'm going to go to the to-do list and then mark that one as done. And let's take it out of presentation mode because it doesn't like it when I make tasks done here. Now let's figure out how to create the C struct representation for scene objects in scheme. So can we replicate what we just did with C code on the scheme side and then send it along? So let's go back to our, let's go back to lib.c. And then we're going to reset this current scene to null. And we can use Control-C-R to start it back up. Now we see that it's a black window again, which is good. That's what we wanted. And now if we go back to our graphics.scm, we see that we had tried to create a C struct using the data types of all the parts of the circle type. So if you remember from before, in lib.c, we have this circle type here on the right side, which has some int 16s for x, y, and radius, and then a nested color struct, which has 4 int 8s for the different channels of the color. So we're trying to replicate that basically here, where we say that we have int 16s that are signed because the x and y position can be negative. I don't know if the radius should be signed or not, but I think that's what I was looking at from the API I'm calling into. And then the 8-bit integers are, or 8-byte integers are, is that right? No, I think it's 8-bit. 8-bit integers are unsigned. So that's all we need for the 0 to 256 color spectrum. So that should actually create a filled circle correctly. So now what we need to do, I think that's where we left off last time. So we had started this render graphic function that's able to pull the scene information out of the graphic that's been sent in as a parameter. And that graphic, let's pull up another thing on the side here. If we look at our basic GFX, the graphic actually is this sort of A-list that we've got set up here. Stream BG, I don't even know why I called it that anymore. We've set a width and a height, and then we also have the scene that has the list of scene members in it. So we're basically trying to pull out this scene from the graphic, or the scene, I don't know what to call it, the graphic that's been sent in. And now we need to process that. And I think that I was reluctant to try writing a loop because typically in Scheme you need to use recursion for that, but I think Guile may have some other looping structures. But honestly, right now I have the mental energy to write a recursive function for looping, so that's not really a problem. And if you are not familiar with Scheme, reason why I'm not afraid of writing a recursive function for a loop is because Scheme has tail recursion, or proper tail recursion, to where if you write a recursive function in the correct way where it calls itself as the very last thing in the function, it will actually internally turn it into a loop from the compiler. So that's a more generalized form of looping, basically just calling itself and internally getting turned into a loop. So let me double check my, oh yeah, we got some background issues here. Sorry for that. I can't wait until I have my own place and my own streaming setup where I don't have to have this stupid circle green screen behind me the whole time. All right, so we want to loop over scene. I think that this is the reason why I'd actually made this make scene function. So I'm going to pass in the scene to make scene. And here, maybe what I'll do at first is just say display. There's a pretty print function. I wonder where the pretty print is. Let's see, Guile pretty print. So if I can pretty print the data structure, we at least see that we have picked up the right thing. It's an ICE9. Do I care enough to pull that in? Let's see. Probably I just need... Here, we'll do this. Oh, come on. Lispy does not like Guile syntax at all. So now we can pretty print... I think it's just pretty print, right? Pretty print scene and just return true. I'm not going to worry too much about that. We'll close this window on the side. And now I'm going to use... I think just Control-CR. So I don't see anything in the REPL itself, which is interesting. Oh, hold on a second. Did I pull that code back in basic graphics? No, I did not call render graphics, so that explains why. Control-CR. Still doesn't show up. Oh, there it is. Okay. So filled circle, post, radius, color. Okay, so it does give me what I want. So now what we need to do is go into graphics and then process the scene. So, I mean, obviously the simplest thing we could do is just call make filled circle directly, but we're just gonna go ahead and write the code for this to make it work. So, make scene. Oh yeah, okay, so I think that's what I was thinking about last time. If we want to have a complete data structure to send over to C, then we need to process, basically get the results of all of the scene items. Let me make sure the stream's still up. Okay, that's good. Man, I hate this backdrop. It's so terrible. Okay, so we'll just do this the simple way, and then we will change it if it needs to be faster. So let's just make it as simple as possible. What I'm going to do right now is use a let. I'm not going to think about this too much. I'm just going to do it. So I'm going to use a let here. Still showing? No, okay. And scene members. And I'm going to call map. And I believe the syntax of map is, does it tell me? You give it a lambda first, or let's call it item. And then, well, maybe I could just have a function. Let's see, define process scene member. Okay. So here we can actually figure out which make function to dispatch to. So in this case, I'm just actually going to go back and give this process scene member, and then also the scene list, because I think at this point scene is just a list of members, which we may have to change at some point. So that should give us all the scene members, and maybe we could just pretty print it on the way out. scene members. Once we have that, then we can try to put it into that overall scene data structure. Once we can pack everything in there. In theory. It'll be interesting to see how that works. Okay, so process scene member. We may try it at a lower level at first too, just to do one struct at a time, and then try to do a more aggregate struct. So process scene member. In this case, we want to use a case, I guess. Or is it a cond? I think it's case, right? So we want to pull the first atom of the list, which I believe is going to be the yeah, the type filled circle. So where did that just go? Case. All right, so car of member. And now if the car is equal to, well, let me make sure I'm going to get this right. If the car is equal to filled circle, then make circle, let's see, spec, yeah. Make filled circle spec. We're going to call it member. And then if it's nothing else, I need to check out, let's see, guile scheme case. It may not show up. No, not syntax case. Let's go to the manual, go to the index. You're gonna load. There we go. Case. Or is it like a programming index? Programming index. Programming. That's not what I expected. Okay, case. Case lambda, syntax case. Character case mapping, case lambda, case. Last expression in each clause. Okay, so we're getting there. Conditionals. All right, so there's if, when, unless, cond, and then case. So key may be any expression, and the clauses must have the form, datum one, blah, 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 or arrow. Yeah, I don't need an arrow. And then else is the last one. Okay, that's where I got tripped up trying to do this in Emacs Lisp the other day too. Okay, so we're gonna just write a message out. Display unknown member type. There's probably a way to format this, but just do a string append right now. String append. Ugh, yeah, this is not gonna be good. Let's look it up. Format. No. Open paren format. Okay, so there is a format function somewhere in this language. Let's see, are we still in the REPL here? No. This site is just so big that I think Qt browser is having a hard time coping with it. Come on, Qt browser, let's go. Okay, so format. Oh, geez. It really did not like me. Format. Never mind. Okay, so let's go to, maybe let's use the info system instead. Yes, I know. Ashraz, that's exactly what I was about to do. Guile reference. Okay, yeah, I know. That's the problem, is that I'm more used to just, jumping straight to a website. No, not API. We want the, let's see, go index. Oh, come on. This is why I don't go to the info systems, because I'm not like an expert at using it. So procedure index, maybe that's what I want. So format. Is that really in Surfy 28? Formatted output. Let's go there. Okay. ICE9 format. Good enough. Okay, so format dest format arg. Dest can be output port T for current output port. Great. All right, so that's good enough. And what's the syntax for the string? Tilde param. Do you have any examples here? Okay, cool. Great. So let's use format. That will save us some trouble here. Format hash T unknown member type. And it's like tilde S, I think. And then we're going to pass in... Oh. Now I got to remember how to get the... Jeez, okay. I got to remember how to get the value of the case. You know what? I'm just going to cheat here. Car member. Let's not worry too much about that. So process scene member is going to get called in the map. All right, so let's try that. Control-C-R. And I'll kill this. Let's just see what it printed out. Pointer. Okay, that seems correct because we just created some native memory. So, yeah, we're gonna have to deal with freeing some of this stuff at some point, which is gonna be interesting, but we'll get to that. All right. So we were able to convert that circle into a struct. So I guess the question is, can you compose those together in the end? I mean, we can make one, which is good. So I have a list of C structs, some pointers to memory, basically. And I want to put those together into a higher level struct. So let's take a look at the documentation really quickly. Let's get out of there, get out of there. We can leave that open for now. We may still need it. So the foreign structs information is what we need. Sometimes you need to deal with C structs, which requires interpreting each element of the struct according to its type, offset, and alignment. And you can make a C struct, create a foreign pointer to a C struct containing vals with types. So I wonder if you can pass in a particular C struct as a member of this list, because if you can, then I think we might be in business. But it doesn't really tell me whether I can do that. I want to see some more examples of make C struct. I might have to go look for like some tests or something that they have in their library. Make C struct. TV type. Parse C struct. Okay. All right, so Guile make C struct. I wonder if anybody's written any blog posts that go into more detail on that. Procedure to pointer, procedure index, dynamic FFI. Okay. We'll skip that for the moment. So I guess the next thing to try would be, let's try this. Let's just see if this works. Define make color spec. And oh yeah, we didn't even really get to, hold on a second. How did that even work? Make field circle member, make field circle. Oh, okay, we're just throwing in random stuff. Okay, that makes sense. Okay. So here we can say make color, and the spec would have to be just a list of 4 numbers. So we're gonna take, I guess that's the next thing. We need to figure out how to pull out the value for a given property in this P list. So for a given spec, we need to rip off the front. So what I'm going to do is say properties, or props, let's call it. Props, cdr, spec, because we don't want to look at the first item. I guess it doesn't really matter too much. And then there is a specific function we can use to find the child list of wherever a particular item is found. I think it's like a seek or something like that. Let's see. Let me go back to info. We don't have info. Info. There we go. We're gonna go up. Up. Let's see. We wanted to go to index. Why are we here again? Up. Okay. Procedure index. AASSQ. Retrieving A-list entries. Was it member? Member. MemQ. List searching. Okay. I think that's where we're headed. Searches list for particular elements. They use different comparison predicates. I think we can use MemQ. And I think MemQ is supposed to return the remaining items of the list after it finds a particular element. So if I were to pull up a REPL and take this filled circle here, let's just pull up a REPL again. If it doesn't break, yeah, it broke. Source expression failed to match any pattern. Define make color spec. Okay, where is make color? Let's just put a T in here for now. No prompt found. Source expression failed to match. Blah, blah, blah. Okay. I may need to have another way to launch a clean REPL. Try it out and check if it crashes. Yeah, that's basically all that we can do. Make color. Okay, let's just put that in there. And we also need to bind it to something. So color. Put that there. Okay. All right, so now we have the ability to type into the REPL, which is helpful. I'm going to use memq. I need to go back and look at the info page. The list is a second parameter, so we're going to look for color out of the list. Yeah, see that right? Okay, so it does give us the remaining parts. And in fact, let me take a look at radius, because I think what it's going to do is give me radius and then everything after, but I can just pull the cdr of what it gives me. So radius. Let's go to the, oh, come on, man. There we go, thanks. No. I don't like clicking with a mouse. Radius. We're gonna put the mouse right back here. Okay, that's what I thought. Okay, so now what I need, define, we're gonna put this in a plist ref. Put this in a library somewhere. I would think Guy would have this, but I haven't seen it yet, so. Let's see, plist ref, key list, or do we want to call that list? Because I don't want to override some name. Info. LST. Yeah, that makes sense. All right, so in plist ref, we're going to use memq key lst, and we're going to use, let's say, catter for that. And we need to use catter because we want to pull the cdr first of the result, which is going to give us, like in this case, if we were looking for radius, we're pulling the cdr of this, which is going to give us 400 color, etc. Then we want to pull the car of that result list, which gives us 400. But we also want to make sure that it actually returns something. So we probably need to be a little bit more careful about that. So if memq doesn't find anything, what does it do? Does it just return false? Let me pull it up to here. So foo. Okay, returns false. So I think we can do like an if let. Does it have? Is there an if let here? Let me check the info. So I need to go back. G. This is the wrong way. Let's see. Info back. History back. Okay. CO. Okay. So I'm looking for if let. No. There's no if let. Okay, that sucks. Whatever. Hey, Crazy Chicken. Yep, I'm looking at the info manual right now. I don't know how far behind the chat is at this point. Okay, so to make this safer, we're going to pull the result first. So let's just say res. We're going to do this. And then there's probably a cleaner way to do this, but you know, it is what it is. If res catter, still a little bit dangerous, but we'll do it this way for now. Catter res, otherwise. Yes, okay. So I think that's good enough for that one. And here we're gonna use, let's say for this one, plist. Ugh, okay, we still gotta break things down a little bit. I wonder if we could do that. So we have a position key. I don't know if we should, you know, break that even down further into specific X and Y parameters, because decomposing this further is kind of annoying, but it is nice to have this a little bit easier to write. So maybe we'll stick with that for now. I probably should be using structs, like actual structs in Scheme, to make this a lot easier. So let's think about that for a second. Or I guess you would call them records in Scheme. So let's pull up info again, because I don't want to be wasting time. Excuse me, wasting time doing something annoying. Let's see, record, immutable record type. That's interesting. Record, RN, RS, records, syntactic, procedural. Okay, records. Record type is a first-class object representing a user-defined data type. A record is an instance of a record type. And I think we can use keyword style stuff as well for this, which would be useful. Make record type, type name, field names. Okay. Returns a fresh record type. It generates new record types. However, sometimes you want to define a record type if one hasn't been defined already. I don't know if I care too much about that at the moment. Record constructor. I wonder if that gives me what I'm looking for. Let's try that really quickly. I'm going to define a record type. Let's go back down to the REPL. Make record type. Scene circle. We can try that. Field names. Position. Was it radius? Color. And unbound variable. Do I need to use a symbol for that, actually? Let's try that. Probably wants it to be a symbol. Okay, so now if I do make scene circle, what does it do? Complains because it's unbound? Why? It should make a creator function. What did it return whenever I... Okay, so it like gave me a record type in hand. Let's look at structures here. First class data type which holds scheme values or C words in fields. Ooh, that's interesting. Gavin says, I assume you managed to access the C functions properly from Guile now? Yeah, I can call C functions pretty easily now, which is great. Structures are lower level than records. That's interesting to hear. When you need to represent structured data, you just want to use records, but sometimes that you need to implement new kinds of structured data abstractions, and for that purpose, structures are useful. Records are implemented with structures. So structure basics. Make struct. Huh. Make v table struct ref s. Okay, so it's like indexed. That kind of makes sense. Check my backdrop. There we go. Make structures from C. Packed array. Okay. That could be interesting. But let's go back to just regular records for now. Make, oh, really? It wants a string as the name? That seems weird. Type name is a string naming of the type. Currently is only used in the printed representation of records. Okay, so it doesn't actually create a type. So then what do you do to actually instantiate? Given an instance of an opaque record type, one cannot obtain a runtime representation. Record constructor return a proceed. Okay, so this is really low level. You're basically, you have the raw material for making higher level types. Because you can generate like a constructor. Let's say, let's go back, grab this. Define my record, and we're gonna paste in that code, and then record constructor, my record. It gives me a procedure, and if I were to actually use to call this as a function, wrong number of arguments. Okay, so it wants to have 3 parameters. So that is like the low level way of putting that together. So data types, let's actually take a closer look. The standard recommended record API, walking through the maze of record APIs. That's the thing about record types in Scheme, is that there's been a few different surfy designs for those, and they're all different in slightly different ways. And I'm trying to do this because dealing with A lists and P lists is going to be a headache. So let's just jump ahead a little bit and try to use the structure. High level record interface, Survey 35, and R6 RS records. So that's the actual, standard now. Define record type. Name spec record clause. Must be an identifier or must take the form record name, constructor name, predicate name. Okay, give me an example. No examples. Okay, so Crazy Chicken says, better do this now before you need to start data-ring. Yes, I agree, because that's going to be no fun for any of us. Last year when I was doing game development with Scheme, I did a lot of stuff, just plain old A-lists. And it was nice from the perspective that you could make your code very functional, but it was also slow because you're just looping over lists the whole time. All right, so let me take a look. Let's go back up. I don't know. I want to get started fast. Give me something with some documentation where I could just copy it and go. Standard libraries for description as interfaces. Define record type, constructor, field name, predicate. Okay, yeah. So you're defining the constructor and what fields it takes, and also the actual fields. There we go. Thank God somebody gave me an example. Define record type. I probably need to pull in this namespace, don't I? Let me just grab that and go down here and get out of the backtrace, actually. All right, so we pulled in Surfy 9, and then we're going to use define record type. And come on now. Scene circle. make circle. You know what? I'm just gonna put the position stuff directly in. Position X, position Y, radius, and color. And then scene circle question mark. And then we have pose X. We're gonna look at scene circle. Yeah, I don't want to keep putting scene in front of everything. Scene circle. Oops, I need to create the next entry. Yeah, setters. I don't really need setters after the fact. I just need to have fields. Post Y. Scene circle post Y. Radius. Scene circle radius. Color. Scene circle color. And now I think that we got it. Now make circle 100, 200, 5 false. Cool. All right, so we got that. Let me just pull that back in here then to our actual code. In our graphics library, we're also going to want to pull in use module Surfy 9. I think so. Why was there a GNU namespace in there? That's weird. Felipe, I don't know if YouTube ate your comment if you were trying to suggest some code in there. Definitely it's possible to get, you know, p-less values, but I feel like it's just more trouble than it's worth to actually use them long term. I'm already annoyed just by what I had to do so far. So REPL-driven development and action, says Crazy Chicken. Yep, that's what we're doing here. Okay, so I'm gonna just take the scene prefix stuff out because I don't know. We'll go with that for now. Maybe it's a mistake, but we can change it later. We can change anything later. What did I just do wrong? Here we go. Okay. So if we were taking an actual circle instead, I guess first of all, circle. Next stop, org mode driven development. Yeah, we're not doing that. Not here. I'm annoyed with org tangling at least. Okay, so we don't need props in that case. And for X, I mean, we can just pull this stuff directly out. We don't even need to have any ceremony on this anymore. So for color, I need to do something about it, but let's see. So on the list, we can say circle post X, circle post Y, circle radius. Don Knuth would love to hear about literate programming. Don Knuth is not going to be anywhere near this stream. And then for color, we need something else. So let's just define a record type for color as well. Core. Okay, so we're going to go with man, this thing keeps jumping around a lot. I don't know what's going on with the positioning. Make color RGBA. We don't need anything fancier than that. Color RGBA. I think that's right? Yeah. Okay, that's the parameters to the constructor. So go up here. R, color R, G, B, R, A, R, A, R, B, R, G. Okay, so that should be enough to get a color type. Tangle-driven development does sound classy. I don't want to do that. It's going to make this way harder for no reason. All right, so color is going to be an actual color struct type or record type, I guess you could say. So in this case, we're going to make color, and we're going to say 255, 0, 0, 255, which makes that a whole lot easier too. And we need to have the C struct versions of these as well. So if I were to say define circle C, I don't know. Circle struct. Let's call it circle struct. And then we can steal this make C struct. This is where we start to get into what we don't know about how this is going to work. Oh, that's not what I wanted. Is it? Okay, let's take the uint8s out. We're going to define the color struct in a similar fashion. I'm going to drop this right in here. I'm going to take out the circle parts. And well, actually, let's do this. Color R. No. That's wrong. Wrong. Delete this stuff. And for make struct, we're done after that list. So I don't know why there's extra crap in here. Okay, so that takes care of that. We want to make sure we get these int 16s out. Int 16, there we go. Delete. And then here we'll go to the uint 8s. Delete. However, we want to probably use color struct here and see if it actually allows me to do that. In fact, let's see. So what did you not like about that? Wrong number of arguments. Make C struct types that. Oh, okay. The actual spec of it needs to be. Didn't kill the REPL. Where did the REPL go? REPL. There we go. Okay, so let's jump back up one level. Let's see. Hey, Alex. Ashra says, I can imagine that Babel's session feature should work nicely for REPL snippet-driven development, similar to Jupyter Notebooks. Well, I would definitely do that for experimentation code where it's not part of the actual code base, but we're trying to figure out something and maybe keep it as a snippet or an example for later. That could be useful. I would definitely consider doing that. Okay, so, So what does that mean then? Can I use a nested list inside of the structures? That's weird. Okay, so make C struct. I cannot call that unless I actually have the data to populate it at the time that I'm doing it. So what you really need is just the spec, which is the list of types that go into the struct. So in this case, let me just take this part out. And then I might need a function like, oh boy. Define make circle struct. Yeah, okay. Cool. So make circle struct. And I want to take in a circle. I also need a function for color struct as well. Let's just do that too. Define make color struct. All this is crying out for some kind of higher level syntax to define these things all at once so I don't have to keep doing it by hand. Color. And then we're going to use make C struct. We're going to pass it in the color struct list. And then for the values, we're going to give it... does it need to be a list? Probably needs to be a list. List color R. Color. RGBA. Okay, so that would give us a C struct instance. And let me clean this part up here too, so I can take this little snippet and then put it in this function. I hope this all works right, because otherwise we're spending a lot of time. Okay, so circle post X for a circle, circle post Y for circle, circle radius, circle. And we also need to say make C struct, circle struct. We're going to drop this in here. And then we also need to make a color struct for circle color circle. And that should be sufficient. Let's delete these. Then join those lines. Let's see. Make circle struct, make color struct. Okay. So both of these look pretty good. I'll move this right here so this is a little bit more co-located. I'm really curious about whether this is going to work. I also have a little typo here, it seems. Let's rebalance this code. Okay, so now make filled circle. Well, we already have make circle struct. That's probably enough. So let's look back at our process scene member. Filled circle. I think that let's just leave it as make circle for now. Because we also need to, I think that whether it's filled or not, it just needs to be a property on the circle itself. And we need to think about the stroke and the fill color. Well, we have color, but that's just whatever's being used for the stroke or the fill at this moment. But we also need to think about the separate colors for things. It doesn't really matter too much right now. We're just trying to get something on the screen. So let's just delete this filled part off. We're going to say circle. And then we're going to go back to basic graphics. We're going to take filled off here. So let's just say circle there. And we actually need to change this now. So from Flux Graphics, we need to export make circle. Yeah, make circle. So we're going to put that in the export list. Make circle. Probably should clean this up a little bit too. Just drop down on some separate lines. And then here we can call, yeah, we'll probably set up a struct for this as well, but for now we can just stick with the A list for the moment. So in this case, we are going to call make circle, and we're going to rip out some of this gunk here. Delete, delete. I believe I can just say 500, 500, 400, and then throw a color in there. So if we do that, I can call, oops. Where is the code going? Is it hiding? Yeah, it's hiding. So then I can pass in make color here. Okay. So we'll see how far we get with this. I don't know if it's going to be the ultimate approach going forward, but let's try it. Control-C-R. Okay, cool. We already got some problems here. Define record type, invalid field spec in subform RGBA. So let's go back to graphics and see why our color record type is not happy. Make color RGBA. Post X. Oh. Something's wrong here. Oh, that needs to be dropped down one line. Okay, yeah, okay, I gotcha. Did not edit that correctly. So we're going to try that one more time. Control-C-R. Source expression failed to match any pattern in form. That is line 80. Right here. Make filled circle. Okay, so I think we can delete that function now. Did it delete the right thing? Yeah, okay. So make filled. Are we still calling that somewhere? Make circle. Make circle member. And we also don't need this part anymore because we actually have the direct. Let's see. Make circle struct is what we want here. Make circle struct. All right. So if we find circle, I can even tell what it is too. I mean, I don't even need the symbol anymore because I can just look at the struct type. Thanks, Ashraz. Ashraz says, read something about functions snarfing in the manual might come in handy for calling the C functions from Guile later on. I'll have to check that out again. I did see that section. Okay, we're making a lot of progress writing some scheme code, but we need to get back to handing this stuff over to C in a moment. So if I were to use cond instead, cond, and circle question mark, yeah, circle question mark member, make circle struct member, unknown member type. Well, I can't really tell what type it is at this point, so maybe I'll just write out the member itself. I think it will tell me. It will give me some kind of text representation, which should include the type, so that could be helpful. So now that I got rid of that, Control-C, R. Unbound variable make color. Who does not like that? Where are we? Basic graphics. Make circle. Ah, okay. I need to export that also. So let's go back to graphics. Go back to our export section and add make color. I think that, whoops, that's all we need there. We're good there. Control-C, R. No prompt found. So you still don't like that. What's the problem? Make colors in here. Oh, is there two of them? Great. That would explain something. Control-C, R. All right, not a list. Circle. I think I need to go back to basic graphics. Whoa, where did that come from? Circle. No. Why did... Oh, I did that on purpose. Okay, I pre-printed it. Well, that's a pretty nice pre-print representation, I gotta say. I mean, it gives you the actual property values. So, in graphics again. Gotta figure out why procedure map, not a list. So I'm using map, process scene member, circle. Aha. Hold on. I didn't put those in a list. Okay, so that explains this. Let's see. Yeah. That's what I need right there. Okay, so now that's a list. If I do Control-C, R. Wrong type to apply. Syntax transformer circle. Which location doesn't like that now? Well, I didn't actually use that. It must be in the graphics layer somewhere. Circle question mark. I mean, it's a real function, which is weird. Wrong type to apply. That doesn't make any sense. So we're calling into render graphic. Render graphic is calling make scene. Make scene is pretty printing the whole scene, but for some reason, oh, okay, yeah, that is a scene. That's a list of structs. For each item there, going here. So maybe, did I do something wrong with the cond? Maybe that's what the problem is. Info. And now we're going to jump to, let's see, let's go back. Cond. There's probably a very specific section I can go to. How about this? Star cond. Okay, there we go. Conditionals. Let's go to cond. Test expression. Any examples? Just to make sure I'm getting the syntax correct. Test guard. I mean, that should be right. I'm calling circle question mark on member. Wrong type to apply. Syntax transformer circle. That is really weird. Why doesn't it like a predicate function? What if I just take this? Oh, hold on. I'll just take this line out and see what happens. Probably yell at me for that else. Okay, well, that worked. Let's go back and see. Unknown member type circle. Okay, well, it should have actually picked it up correctly. All right, so circle question mark. That is what we call the predicate type for that. It's very strange. I guess the question is, do I need to go back to what I was doing before just so we can get unblocked here? Because we need to actually try creating something with this really quickly. Because otherwise we're just spinning our wheels. I really don't know why that function is not happy here. So maybe if I go back to con clause must look like test expression, where test and expression are arbitrary expressions, where expression must evaluate to a procedure. Okay, you're passing the value directly into a procedure in that case. Let me check that really quickly. Make circle struct members. I could do this. Probably, whoops, probably not what I want to do. Oh, hold on, Lispy, what are you doing? So I'm gonna drop that part. Circle member. Oh, did I not close this out right? No, that's right. Okay, we'll try running it again. Wrong type to apply. Syntax transformer circle. That doesn't make any sense. Did I define this thing incorrectly? What is member in this case? It's got to be an individual. I think I'm pretty printing it. Let's just do that here. Pretty print member. Also, let's do this since we can do that. Let's pretty print circle itself and see what circle is. All right, so syntax transformer circle. Oh, okay, so is it? I'm trying to call circle like a function, but it's treating it as if it's something else. Because it says wrong type to apply. Do I need to call that differently? Okay, so we're trying to apply whatever is contained inside of circle, which apparently is a syntax transformer. That is confounding. Okay, let's go back to info. We're going to go back to Surfy 9 predicate. Bound to a function to be called as predicate. Oh, yeah, it's the predicate we called it. Returns T or F according to whether object is a record of this type. That's for immutable record types. Record overview. Surfy 9 records at the same page we're just looking at. Yeah, so we have the example here. We have employee. Make employee name, age, salary, employee question mark. Creates a new employee data type. Yeah, you should be able to just call it employee question mark. Record type employee. Define Fred. I'm really confused. Ordinary top level defines they can be redefined or set as desired, exported from a module, etc. Non-top level record definitions. Set record type printer. Functional setters. When writing code in a functional style. Ooh, that sounds cool. Never alter. Sweet. I like that a lot, but I'm not going to use it right now. Yeah, I just want to know why this is not working. Okay, how about this? How about this? Let's just stop using con for a second and see if that helps. So if circle member make circle struct member. You know, member is the name of a function also. I wonder if that actually is a problem here. So we're going to say if, and then else we're going to do this format. This is not long-term code. We're just trying to figure out why circle is not working in this case. So Control-C-R. Wrong type to apply. Syntax transformer circle. What the hell, man? Wrong type to apply. It just doesn't make sense. How about we look up his error? All right, now. Why is it not actually writing it out correctly? Cond error, wrong type to apply. Whatever. Cond equal. That's not exactly what I'm looking for, though. Because it can't even, like... Here, let's do this. Even simpler. Circle question mark member. Pretty print. We're just going to get real hacky with this testing. It does not like that at all. Define above its first use point in the file. Okay, well, that's going to be really annoying if it's the case. I can't imagine that, though. It just doesn't seem right. But what we're going to do is move these structs, the struct definitions, up to the top of the file, just in case it has something to do with it, because somebody on the internet said so. Because, you know, you can always trust people on the internet. We'll just drop them right there. And if this works, I'm going to be really upset. I have a feeling it won't. Oops. Control-C-R. You gotta be freaking kidding me, dude. There's no way in hell. It can't have bound that already. Whatever. It works. Let's move forward. So let's go back to the cond. That should be sufficient. which is basically what I was thinking last time when it wasn't. So let's see. Control C, R. All right, so wrong argument in position 1, expecting struct T. Yeah, well, where? Especially me, give me all your Bitcoin, I will give you a reward. Yes. I trust you completely, Ashraz. Okay, so we bored some people to death with that one. Sorry about that. Let's see now. Wrong argument. Oh, but okay. All right, I see why this is a problem. I think it's the value of this is being passed directly into make circle struct. We need to actually just pass in member here. We'll see R. Too few values in procedure. Write C struct. Cool, and we're making some progress here. So, which one does it not like? Make C struct. Too few values. 3333. So this seems to be the point where it tries to put together the two structs. There's got to be a way to do this. Like, it must be possible to do this, like a nested struct, without having to, for each type, be completely explicit about it. So make color struct, C struct, color struct, make C struct, circle struct that has color struct in it. I haven't seen any complaints about that part. Okay, so Guile, nested, make C struct. Who knows if someone has asked this question online somewhere. No. Sample Guile extension, probably not. Okay. Let's see. It's not giving me anything really useful here, information-wise. The only other thing I could do, potentially, still doesn't seem right. I was thinking I could possibly just like insert this color struct list directly into this whole circle struct, but then make color struct is not going to work the way that I want it to. What I want is for that pointer to be sort of pulled in, I guess, but I guess it doesn't even make sense practically speaking. Okay. Let's take a step up the ladder for a second and look in the manual. We're going to go back to the index make C struct. Foreign structs. You need to deal with C structs requires interpreting each element of the struct according to its type, offset, and alignment. There's got to be a way to do child structs. Let's go back up to the top here, foreign function interface. Pointers into the ether. Let's look at advanced examples. Struct. I think we had seen this one already. Passing structs as foreign pointers. Yeah, so this is just long fields. Gavin says, started using CFFI in Common Lisp just to see what it would be like, and it's been real nice. Didn't even have to write a line of C. Yeah, with a good FFI, you don't really have to do much. In Gambit scheme, I was able to use some higher level constructs to define C structures. And I'm thinking maybe there must be something like that in Guile as well. but I haven't found it yet. Okay, so foreign library function. Hold on a second. Let's go back. Foreign library function. Some mem copy stuff. All right, so this get time of day. Archetypes, there's 2 pointers. Let's think about that for a second. Okay. So I think that's the only way this can work. I can't do nested structures, but I can do structures that have pointers to some other structure, which is kind of terrible because to free everything, I basically have to walk the entire tree, which is not the worst, but it's not what I wanted to be doing. Okay. So I basically just need to change my structs on the C side, and I think I should just be able to have pointers in that case. So what if I did, let's just try it on scheme first and see if that resolves everything, and then we'll think about it. So the thing we saw just now in the info page was just literally a symbol with a star. And I'm quite sure that the structs also supports that. Yeah, alternatively, type must be, it may be the symbol star, which in this case, if a pointer is returned, type may also be a list of types, which in the case of a struct, hold on. That's size of, wrong. There was a list somewhere of the actual types you could use, I think. Okay, anyway, I'm pretty sure that's gonna work. Let's just give it a shot. So for circle struct, we actually want to have a pointer type here. Are those N16s actually? Hold on. Let me go back and double check something really quickly because I think I did something wrong. Okay, so that's actually, okay, that's a value. Okay, fine. So star. And then I can pass in make color struct here if I have that be a star, which is effectively a pointer. So this should work. Let's see, Control C R. Yeah, I think that worked. And it's a pointer. So it may be the case that on the C side, everything needs to be, I can't have any nested structs. I have to have pointers to everything, which is not terrible. Not what I wanted, but not terrible. Okay, so how about this? Let's go back over to lib.c. Circle. Color now needs to be a pointer. And then when we initialize this, this also needs to be a, well, I mean, this is still our example here. So that should be fine for that test. In fact, let's do this really quickly. So do I actually use that color in this? Yeah, I do. So let's do this. Color, come on now. So this is going to be an indirection pointer now. And this, we're just going to double check that this still works. Okay. So if I were to run the code, let's compile it first, then run it. Cool, the circle is rendering, which means our pointer is now working. So now all I need to do is go back to the graphics code. Now, if we, for our actual array, how are we gonna do this for arrays? Do we need to put together a linked list? I don't really want to do that because it's going to make things really inefficient. Yeah, anytime you have data structures that are just, allocated on the heap and you got pointers to everything, then you're just like thrashing around with the cache, I think. I don't like that too much. I think the only way to avoid this problem is to generate a full packed data structure, a full byte array, effectively, myself with a byte vector, and then unpack it on the other side so that I can have it all be directly in memory without having pointers. But we're not going to worry about that right now. We'll just get this working first, and then we can make things more fast later. Felipe says, what if you make some primitives in C itself and provide them for Scheme to use? Well, actually, you make a good point, actually. So maybe, let's see. Let me think about that for a second. I'm going to have pointers anyway, no matter what I do. Because in my, in lib.c, this whole scene member construct, it's an array of scene members that is it's a full array. It's not like a linked list or anything. So we have those things adjacent in memory. But then as soon as you try to access the member, you're reaching out to some arbitrary location in the heap. So that part already fails, but yeah, maybe it doesn't matter. But I like what you're thinking, Felipe. If we could just call directly into some C functions for creating these structs and not have to bother with defining structs in Scheme, then we can get access to that memory directly and manage it however we want under the covers. Yeah, so here's what we're gonna do. We're gonna run for what we got right now, but I actually like your idea, and we might switch to that after we get it working, and maybe make a commit so we don't lose what we've done so far. So let's do that. So where we're at now is that on the graphics, the Scheme side, we have the ability to create a C struct effectively, or a pointer. Yeah, the more I think about it, the more I think that the way you're talking about it is probably the right way, because we know for sure that the memory that's being created for that struct is the right stuff. But let's see. If we have our circle struct, then how can we pass that across? If what we do is make an array, the problem then becomes, how do you make a single array of the scene members unless you make like literally a linked list? I guess the alignment is going to be fine if you just have... How many items can that thing take? Basically what I'm thinking is this whole make C struct function. Ugh. Make C struct, I don't know how many things it can take in this list that you pass in for defining the data. I feel like there's got to be a limit somewhere. You couldn't just have like 1,000 items. Maybe 100 you could. But really what you would end up with is a generated list of, what would it be? Scene member. It's going to be a uint32. Well, scene member is a... Why have I got a uint32 there? That seems pretty big. Anyway, uint32 and then a pointer. So theoretically, it's going to be 64 bits wide, and it should be fine. Yeah. I think that might be the right way to do it. I may just need like a C API for creating this stuff. And then I could basically just say add scene member. So let's look back at the graphics function for init graphics. We have this foreign library function. We have the name of the function, the return type, and the arg type. So we can take a pointer back from a function. So if I call into a function for, yeah, that could work. Just for making every little piece of this, to be honest. Okay. But we may need to go back to, we'll stick with this for now. Make circle struct. Let's make a function in lib.c, make circle struct. How about that? So we want a void pointer, make circle struct, and then we need to have the same types of values. So let me just copy these really quickly down here, just so I can see them. So sint. Well, can I? How about this? Can I do that? There we go. That's better. So then I could actually allocate it myself with malloc. Yeah. So Felipe has the same idea I do. It has some kind of add to scene type function. If required, C can make a dynamic array copying when necessary. Yep, I agree completely. Basically, use realloc if I have to, or something like that, to extend the size of it. So it's like I need to have like a staging scene that can be flipped to the new position, something that can be built up interactively. And yeah, that seems much better. So let's go with make circle struct. That could be fine. I don't know if I need to tell it it's a void pointer here, but let's try it without first. Let's be more explicit. And then we can also do, wow, what just happened? Color, make color struct. And in this case, we're going to grab the values for color, which are all these uint8s. Paste that there, pull them all up. Okay, so malloc. Let me pull up the docs for that because I don't remember the syntax of malloc at the moment. Like I said, it's been a while. So C malloc. I think we're making progress here. I mean, it's not as much as I was hoping to see, but we might hit, get out of here. We might hit the right thing pretty fast. All right, so is that all? Malloc, standard lib, is that where it's at? Standard lib we got. All right, so we're gonna say color, color equals, is that right? Yeah, void pointer, malloc. We need to cast it. Yummy malloc, calloc, realloc, and dealloc. Yeah. Malloc, was it size of? What is size of? C, size of. Yeah, I know. I should know these things, right? But I haven't written C in a long time. Size of in C, is that just size of? Okay, size of type, cool. Size of color, is that enough? I need to cast it to color. All right, and then color R equals R. Automatic type promotion cast is unnecessary, thank you. See, it's nice to have C and C++ experts in the chat. They can tell me whenever the things I'm doing are unnecessary. R, G, B, A, B, G. All right. And we're going to do the same thing now for circle. I need to return that too. Return color. Circle. 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 Want to make sure we get that size right because that's going to be a headache if not. Circle. So what is it? X and Y? Okay. Let's simplify this. X, Y. And then radius. Radius. Okay. And then color. Circle. Color. Equals color. So now, in theory, I should be able to invoke these across the C boundary and get back a pointer in scheme. So what if I remove make circle struct and make color struct, and instead I set up foreign function bindings for those. Foreign. Where is it? Here we go. Let's copy this whole thing there. Define make color struct. Drop that down. Okay, so this is going to be make color struct. Return type is going to be a pointer. The argument types are going to be uint8. This is color, right? Yeah, okay. I think that was the right one. Whoops. Yeah, uint8. Okay, this function snarfing. Oh, you mean like automatically picking up the definitions from headers? Yeah, that could be helpful. So we don't have to keep doing this by hand. That would be really annoying to have to keep doing it by hand. All right, so now I'm going to also do the same thing for make circle struct. Make circle struct. And then in this case, we're going to use, where was it? This one, the int16 set with the pointer at the end. Okay. Let's see if that works. So make circle struct. In theory, we should be able to just pass those same things on. Let's try it, see what happens. I need to compile the code first. Control C, Control R. Unmatched bracket? Whoa, what? Recompile, please. Okay. Oh. Abnormally. Radius undeclared. Okay, thank you. libc. Radius is right there. What's the problem? Did I make a... Those are supposed to be commas and not semicolons. Can I do a macro on that? No. Okay, let's just do this. So, annoying. Okay, that compiled. Control C R. Wrong number of arguments to procedure. Okay, so one of these needs more arguments. Missing a return in make circle struct. Thank you. Return circle. What is that? Okay. So I'm missing a parameter on one of these somehow. Let's actually check that backtrace really quickly. Wrong argument in position 1. Okay, so it doesn't like something I'm passing into it, apparently. Make circle struct member. Oh, hold on. Right, because I don't have the breakdown anymore, I need to basically do this. Ah, oh boy. Ashraz gave me the cheat codes. So here in make circle struct, when I call it, I need to actually call it correctly. Ah, that's not what I wanted. I want I want this. It's probably not going to copy it. Nah, it's not going to copy it, is it? I got to do this first. So now let me jump back to make, there it is, right there. Okay. Okay, and now that should all be good. Member. Circle color member. Okay, so that should help. Come on now, still the same thing. Wrong argument in position. Oh, hold on. Make circle. N16, N16, N16 pointer. So there's 3 numbers here. And then the result of make color struct, but it could be complaining about that one actually. Hold on. That is what the problem is. Okay, I got it now. So it's almost like we need a wrapper for these, which is a little unfortunate because I don't want to have to do that, but let's think about that for a second. It's nice to have this function directly here, but we need a way to translate the contents of the struct on this side. Well, I guess we're back to the question of how should we represent it on the scheme side? So I don't, well, okay. I could do this. Thanks to the nesting properties of scheme. Circle color member, and then wrap this and say color R color. I do not like this, but maybe it will work for now. RG, RB, RA. Okay. That worked. So it seems that we've been able to create the memory using the C side functions right now, which is very promising. Now that circle did not come from the scheme code. I need to go back and remove this assignment to the test scene, and we're going to put it back to this. Now, what we could try to do, like Felipe said, we could pre-allocate the test scene. And then add stuff to it by calling functions. So then what that might look like is something like void add scene member. And then we're just going to call it a void pointer for now, but we'll be a little bit more specific about it shortly. So scene member, I suppose we need to say what the type is. We could say that it's the numeric types. Let's just say type circle. Let's not say filled circle anymore. Filled. Okay, let's change that. Okay, we're getting close here. We're getting really close. So add scene member. We can say what the type is. I think it had that as a uint32. Uint32 type. So if we did that, then basically the job here would be add the member in the member array. And we can keep a pointer or an index to the number of members. Actually, we have that. We have the member count. So So we can initialize a scene. Hey, God. Nice to see you. So in this case, what we're going to do is, I guess we're going to malloc here. Can I malloc outside of a function? Or maybe what I should do is init scene. So I'm going to have a function called init scene, or add scene member, void init scene. And then all that's going to do is set the current scene, which is probably not the right thing to do, but we're going to fix this. We're going to make it right after we get it working. So current scene equals malloc, size of. Now, yeah, that's fine. So size of scene, right? Is that a type we have? Scene? Yeah, so scene is a type that has uint32 for the member count and a members array effectively. So we're going to allocate both of those things. What we can also do is define here, define initial member size, I guess we could say. Let's call it 100. I don't really have a reason other than just, you know, not wanting to take up too much memory. And then with init scene, we're going to allocate the scene, current scene. Probably should do this, scene star new scene. Let's not mess with stuff until we're ready. Here we go. So we're going to malloc that scene. We're going to say that the new scene, what do we call that? I really need to have or code completions here. Member count, it's going to be 0. Change it to new scene, and then we're going to say the members. Is that called members? Yeah, members equals malloc size of. What did I do wrong here? Then we're just going to set this to current scene equals new scene. To synchronize this. Okay, so malloc size of, and I think the scene member that we want. Scene member. Yep. So we're trying to allocate our scene member array, and we're going to multiply that by initial member size. Yeah, I don't know what's going on with electric indent mode. It's kind of weird. Okay, so that should give us the initial scene information. In fact, I can init scene here. May need a better place to do this, but we're gonna just put it there right now. Create a blank scene. And now that we have that, inside of add scene member, to check if we've reached the size limit. Then what we can do is say that current scene. Oh, okay, I am getting code completions. That's great. Only for things that are defined inside this code. Apparently anything else that's from an include is not working. Members, current scene, member count. So we're going to add it wherever the member count is. Then member count plus plus afterward. I guess we could just do that here. Right? Is that good enough? I don't know. We'll find out. So I want to grab that one. So scene member, new member equals new member. Type equals type. New member. Props equals props. We'll change this variable name to be props. Okay, so now we should be able to call across to take one of those data structures that we allocated using the C layer here. So it calls make circle struct, it gets it from this layer, and then it just passes it right back and says add scene member. So what we'll do is make another foreign function interface for add scene member. Return type is void for now. About the C standard, you're currently using C99 in at least 2 instances, late declaration in the for loop, and C style comments. Interesting. I'll have to look into that. So, int32. Whoops. What do I do? Yeah, uint32 and pointer here. Nicholas, that is called keycast. All right, so add scene member. Whoops, I need to make sure I get the right function name here as well. So add scene member. Okay. So now, in theory, for each of these, make scene, pretty print scene. Don't really need that anymore. So for scene members, process scene member. I could store the result of this, and then if it actually does return something, I could just call add scene member. That could work. Okay, let's try that. Let pointer. Let's try to eat this up a little bit. Probably need a better way to handle this. Okay, so we're storing the pointer there, and here I want to return f false. So then in this let, is that the right one? No, I think it's the next one. Okay, so if pointer, or is there a when pointer, I can call add scene member. Oh, and I need to have a type also. Let me think about this for a second. Here's a better way to deal with this. But for now, we'll just stick with it. I'm gonna hack it in, okay? Pointer. It's actually 1, isn't it? Or is it 2? I don't know why I chose 2 for that. So add scene member. And do I have... Okay, it's closed. Good. Let's get rid of that. So now, in theory, I should be able to add that scene member, and hopefully it's going to show up on the screen whenever I do that. So let's compile the C code. I think I must have a binding. All right, so it doesn't like something here. Type filled circle. Oh, use it somewhere else. There we go. Is that the only one? uint32. Did you mean... Okay, uint. All right, so that's the only one. Control C, Control R. Another problem. Current scene. Incompatible types when initializing type scene member. Is it because I didn't need to cast it? So members. Oh, should I do a reference? You shouldn't need it, right? Initializing type scene member star using type scene member. So is that compiler driven development? All right, so members in this case, members is a pointer to begin with. But are we saying that maybe it's just something about C that I'm not remembering. I don't think this is going to be right, is it? I guess it could be. Okay, well, the compiler liked it. I'm a little bit skeptical, though. Somebody in the chat tell me if I did something stupid there. Okay, so now Control-C-R. Ooh, I think that's real. I think we just did that. So it looks like we just managed to get something on the screen that came from Scheme. Let me move that circle a little bit just so we can verify that it actually happened and we're not just hallucinating. We're gonna go to basic graphics.sem. Oh, is that why? Like, I'm not even using that width and height. That can't be the case. All right, so 500, 500. Let's say a Y position of 200. And also we can make the diameter 100 instead. And then we can make it chartreuse, I think. Control-C, Control-R. Hey, it worked. So we are actually translating information from Scheme to C at this point. And thank you to Felipe for the great idea about basically just calling directly into C to create those objects instead of having to deal with the problems in the Scheme layer. I mean, it's probably possible to go further with using that stuff that's built into Guile to make C-Struct, but I think that it has its limitations. Sherry colored. So we have something drawing, which is great. Now, I still wonder why this window is such a weird size. It just doesn't make any sense to me why it's that size. Not a problem I really want to try to solve right now because we've got about, I don't know, 25 minutes left in the stream. Let's actually go to the... Let's see, figure out how to create C-Struct representation for C objects. We did that. Transmit drawing instructions to the renderer thread. Yeah, what we're doing is not perfect. In fact, maybe what I should do, we've got that working now. So that actually does work. So we can quickly try to come up with a better approach to transmit the new, or basically flip the scene. So by that I mean in the rendering layer, oops, lib.c, when the rendering loop is happening, we're taking the current scene. Let's see. Yeah, we're taking the current scene and we are just rendering what's in it. But what we need to do, oh wait, I did something wrong here. I should be doing this. Okay, I caught a bug. I need to actually use the scene that I'm passing in and not the current scene. I don't want that global variable. Okay, so render the scene. So we need to flip the scene that's currently being built with the scene that's currently being rendered. So if I have a separate scene variable, so we have current scene and we're gonna call it the staging scene. And when we init the scene, I think init scene should actually init the staging scene. And then there could be a function called flip scene or promote scene, I guess promote staging scene, void promote staging scene. And this is gonna try to call into SDL's event loop to like say, hey, here's a new scene you can use for the next frame. So SDL event loop. I need to figure out what the function is for injecting an event. Okay, we'll start at poll event here. There's a rocket in the mode line. I think I have LSP mode running right now. It's got CCLS loaded up, but it can't actually pick up the includes correctly. Poll event, let's go to push event. That's the one I want. KF. SDL event. Two-way communication channel. I just want a generic event. I just need like a signal, basically. So is there some really generic event I can use or just make up my own code? User event. There we go. LJ. Structure that contains an application-defined event type. I need to register it. Okay, I don't like that too much, but that's fine. If my event type is not -1, SDL register events. SDL memset event 0 size of event. Okay, you're basically clearing it out. That seems wrong. My event type. User code. Okay, so we're just like register events apparently is just returns you like a new allocate a set of user-defined events and return the beginning event number. Okay. Just gives you a unique event ID. Event.user.code, so data1, data2. Okay, that's cool. Data pointer. I like that. Push event. Okay. So I can do part of that here. First of all, in my init SDL, I need to register my custom event. I guess I should do that after SDL init. Register custom event for scene flipping. So then, where was that? My event type, which is a terrible variable name. Guess I'm gonna have to make that a global variable, which I really don't want to do, but don't have a choice. So uint32, I think it was, right? Yeah. Scene event. Yeah, compile commands.json. Yeah, I'm not crazy about that. So CMaker Meson can make that. That'd be pretty useful, I think. All right, so set that to -1 to start with. And then init SDL, I want to say scene event ID equals, oh, come on. My event type. Okay, so SDL register events. I'm just getting a custom event ID. And then on promote staging scene, I'm not gonna bother checking it. Let's just do it. Size of event for SDL 0. Okay, well then why don't I just use that instead? Shouldn't that be a pointer or a reference? How are you gonna 0 it otherwise? Okay, so we zeroed it out. Fly make mode can work with a makefile. That's cool. Okay, so type equals scene event ID. Get out of the way. Is that right? My event code. This is some random thing I decide. Okay, user defined event code. Value obtained for register events. Okay, so we're just gonna make all these 0. Actually, they're already 0 anyway. It's been zeroed out. So we're gonna push the event. And on the scheme side, we can make another foreign function invocation that's able to promote that. So if we go back up to the set of functions here, we can call it promote staging scene. And we're going to put it here too. Promote staging scene. And I think we're void on both cases. So archetypes, can you just leave it be an empty list? Maybe I just do that. Wow. Good luck, Crazy Chicken. That's crazy that you're shipping out. Very, very best wishes to you for health and safety out there. It's been nice having you around on the streams and in the Discord. All right, so got that done. We're almost out of time on the stream, so let's just see if we can really quickly get this moving. So SDL event type. So I can do a case on my scene event ID. Is that right? And then break. And I guess what we can do is current scene equals staging scene. Yeah, we're gonna end up leaking memory, but I can do init scene. This probably needs to be in a function somewhere, but we'll just do that for now. All right, so current scene equals staging scene. And then we've got a fresh new scene to accept input. So promote staging scene. That should be enough. So init scene, what if I do this? Probably need to do more than one. So, well, no, actually I don't have to do that at all, because no scene just means it's going to show a black screen. So now let's go to basic GFX. Okay, no, we don't need to do that. Render graphic. So after we call make scene, we're gonna call promote staging scene. Okay, so now we're gonna compile the C code. Whoops, what did I just do? Real C control R. Why are you asking me about that file? Yeah, sure. Case label does not reduce to an integer constant. Oh boy. That's interesting. Because it can't be a constant. Because I just got it assigned. So maybe... Where was the loop? Maybe I need to do this first. So if event.type equals scene event ID, then basically do this stuff here and then continue. And then take that part out. I don't like that, but you know, it's not, I don't know, actually, else. I don't need to continue. Okay. Promote staging scene. Why did you have a problem with that? Oh, my fault. L value. Oh, okay. LCL0 is a macro. Great. So already it must have 0. Why does it sound like we're listening to the same song over and over again? Probably because we are. Okay, that worked. And Control C, Control R. Kyle Reppel segmentation fault. Excellent. That's an interesting idea, Ashraz. Idea for the next stream: work on a temporary branch and have Emacs automatically commit and push to GitHub. That way we can also follow along in the code. That's not a bad idea. Okay, 10 minutes, 10 minutes. I need to make this work. Segmentation fault. Now, staging scene. Init scene, new scene, staging scene. Okay. Staging scene. So I wonder which part of it did not like. What if I don't call init scene? What if I do nothing? How about that? What if I just do nothing? Let's just see if the event handling doesn't cause it to break. So Control C, Control R, Control C, R. Segmentation fault. Okay, so what's different this time? The fact that I added the promote staging scene. If I just don't call that, is it going to be happy? Control C, Control R. Also segmentation fault. What did I do differently this time? Was it that I added the function? Maybe because I didn't pass the archetypes? Wow, something really bad is happening. Let me clean up some stuff here. I don't need that anymore. Don't need that anymore. I don't need that anymore. I must have changed something in a bad way. Okay, add scene member. Okay, add scene member must be put in the wrong place. Add scene member. Current scene. There we go. That's a problem. Okay. So staging scene. Now if I go back to graphics.scm and uncomment some things. Okay. Let me join that. Let's uncomment that. Should be good on that now. Let's recompile the C layer. Okay, and then run the REPL again. Current scene. Where else? Oh, that explains it. Staging scene. Nope, there it goes this time. All right, so now, in theory, we go to basic graphics. It should have drawn it already, I think. So let's run render graphic again. Oh, okay. So I did not. That's what happened. Okay, so here, let me kill that. So in the scene event ID, I took this out. So I need to put this back in. Control C, Control R, and then Control C, R. Still no scene rendering. So current scene equals staging scene. Let me just make sure I'm getting that event coming through. Printf, switching scenes. In fact, I can't actually see this. That's one thing that is a little bit unfortunate about this. I don't think that when I print things out, the standard out, it doesn't seem to come through to the REPL. It's almost like I need to have a log file or something. Yeah, I know. The pressure is tangible because, like, you got 5 minutes left and it almost works. Staging scene. Current scene is equal to staging scene. All right. So staging scene is new scene. We're knitting this new scene here. We've seen that part work before. Add scene member. That's so strange. Add scene member. This is just calling render graphic. Render graphic should work the same way. Make scene, promote staging scene. Well, let's try one thing really quickly. So add scene, remember, goes to staging scene. Am I doing something in the wrong order? Current scene. Who is using current scene? Current scene, current scene. It's just that. Okay. That should be fine because we've allocated that. It's not crashing, it's just not rendering. Okay, so the quit works, it seems, because whenever I close the window, it seems to exit. So it's getting events. Render draw color. Here we go. Let's do some hacks. Add scene member. Oh, did I miss something here? No. Okay. Let's just do this. Current scene. This is going to be terrible, but we're going to do this just to see if it works. Equals staging scene. Okay, so that works. So the flipping is what's not working right now. It must be that event. You know, super risky, super risky. Promote. Current scene equals staging scene. We're gonna clean it up later, okay? So we're just gonna do this now. To do, this is bad. We're gonna build this. And then we're going to run and Control-C-R. Okay, so now let's see if we can actually update the scene right here. So I'm going to move this to 600, 200. And then I'm going to, let's see. Probably shouldn't run show preview window again. Let's see, Control-C, Control-B. Okay, so it has 2 this time. Because I'm not a knitting, so that sort of worked. Sort of worked. Okay, how about this? Real quick. We'll do the same thing we were doing there before. So current scene equals staging scene and knit scene, just to clean up the previous. All right, Control-C, Control-R, up. Segmentation fault. How did I do that? So is that where it's happening? The init scene call? Init scene. So we're allocating a new scene. And we're setting the staging scene to it. That's pretty weird. Yeah, well, it's probably wasn't rendering anything at all. Interesting that init scene is causing that. It must be a timing issue of some sort. Yeah, it's got to be a timing issue. It's man, I wish that event worked. Huh. I think he's just not picking up that event. Promote. Because when we do this directly, it's fine. Let me double check that example that I saw. So SDL mem set. Let's try this. I don't know. Who knows why? Instead of 0. I don't trust 0 necessarily. Event type. Maybe I should clear some other stuff too. Should be cleared. I mean, the whole thing has been zeroed out effectively. But the thing is, it's not allocated. This is like on the stack. I don't understand how this is supposed to even work. Unless push event copies the data. Pointer to the event structure you use to push onto the queue. It's gone. it says it's copied onto the queue. If you actually copy it, that's fine. I don't really trust it. But maybe it is fine. All right, so Control-C-R, segmentation fault. Init scene. Anywhere I'm calling init scene, it flips out. Segmentation fault again. Something's wrong. What if I don't push the event? Segmentation fault. Did it again somewhere. Staging scene. I took out all the hacks. Yeah, it might be time to get GDB. I don't know which function's calling at this point. And I don't really have time to pull up the debugger. I may have to call it. Let's see. Control-C, Control-R, Control-C-R. Okay, so it's still seg faulting. Regardless of what I'm doing with the events. Is there something I'm calling here? It's gotta be... It's got to be the call to add scene member. Let's just do that. Ugh. And return true. Whoops. Okay, so it's the call to add scene member for some reason. Is it uninitialized at that point? So back in libc, we call init scene. The first thing that happens in init graphics. Oh, ha 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 ha. Terrible. Okay, let me do two things. I know exactly what happened. So I need a way to say that graphics are already initialized. Can I put a variable here? Uint 8. Graphics initialized equals 0. If graphics initialized equals 0. This was happening here is I forgot to add the initialization back. I'm going to say graphics initialized equals 1. And then back in basic graphics, I can turn show preview window back on. Control-C, Control-R. Error. Do you mean uint 8? Sure, yes, I mean uint 8. Okay. All right, so at least we're back to not crashing. See ya, Bill. Thanks a lot. All right, no crashing is good. And I need to go back into graphics. I added the scene pointer back in. Did I comment anything else out in the code? The event pushing is there. Okay, we're gonna put the hack back in. Okay, so we got this circle rendering. Go back to basic graphics. Undo some changes. And then Control-C, Control-B. Okay. Well, updating is not working completely, but we did get enough happening today that I feel pretty satisfied with, being able to send things from the scheme layer to the C layer and have it work. So really it's just a matter of figuring out the issue with the events that cause a scene to flip. Once we have that, then we should actually be able to dynamically update the scene. So we got really close to doing that, which is great. Was there anything else in the to-do list that we finished today? Make sure we can re-eval the scheme code. Yeah, that's not fully working. Yeah, we're sort of doing that, but it's not fully working. So I'm not going to call that one done yet. But in the next stream, I think we're going to be able to get the scene updating every time you update the document. And then we should be able to start building on that. I feel like we're starting to figure out the shape of the interaction between scheme and C. So I'm a lot happier about that now, at least. And anything else? Yeah, I think that's it. Let me just go ahead and copy these down here to the next steps section. To do, let's see, figure out why scene flipping doesn't work. Event problem. Okay. And that's it. Thanks so much, everybody, for being here today. I really appreciate the interaction and all of you who are helping me try to figure out what I'm doing wrong at every step of the way. It's super helpful to have people, you know, contributing to the discussion. Gon says, what about bool? Bool, I could use bool. Yeah, I just haven't done it yet. I think there's like standard bool.h I can pull in. So anyway, catch me back here on Thursday, same time. Was it 2 p.m. UTC, and we're going to continue where we left off. And until then, thanks so much for being here today. I really appreciate it, and keep it creative. We'll see you next time.